Alright, in this video, let's get started with the examples from Keras. We have adapted from the examples and made some changes. Alright, so what we're going to do is we are going to take a look at the entire code piece by piece. So we're going to analyze the piece, run the piece, and then move on. And for sanity check, I also have the entire code right about here. Alright, let's get started now. So let's go to the top all the way, and here we first are going to import the libraries. So that's obvious. Let's start with the importing of Keras itself, and then you need to import the models. So in this case, we're going to be using sequential models. So go ahead and say keras.models import sequential, and then you need the layers, whatever you're going to use, dense, dropout, activation, and then the optimizers, that is SGD. Now if you want to use something else, you can import the specific component as well. So how do we understand what's available? So that's from the documentation. So you need to go to the documentation here and you need to take a look at it. So here are the models, the layers, and then let's say optimizers. So these are all the optimizers available for you. So if you want to import, for example, let's say RMS prop, then you can say import RMS prop. Awesome. So that's the first part. So go ahead and say shift enter. And we also are going to use numpy. I almost forgot to say that. Alright. The next is to generate the dummy data. So this is an important piece when you're going to get started with learning neural networks. You don't want to spend too much time to get the data, clean the data. And most of the times in the beginning stages, generally working with the data is a bit difficult. So you want to be able to generate your own data. So get clear with your concepts of neural networks and then worry about the actual data from your use case. Here you're going to make two sets, one for the training and one for the testing. So each of the training and testing sets will have the data and the labels. So basically a set of information and then a corresponding class which it belongs to. So for that, you're going to make 1000 samples of 20 points. That is the shape of the X train. And then Y train will be in classes of 10. And you're going to do this by using the two categorical function from the Keras utilities. So how do I understand that? So you can go to your documentation, find utilities right about here. And then utilities has many methods and the two categorical is right about here. So what it does is it converts a class vector, basically integers, to a binary class matrix. Arguments are class vector to be converted into matrix, that is integers from 0 to num classes, and num classes is the total number of classes. In our case, it's gonna be 10. Alright, really useful in generating data. Alright, so coming back here, next is the test. So here you're gonna make 10% of the train, which is 100, and still gonna carry the same shape of 20, and the number of classes obviously are gonna also remain the same. So how do I understand this? So let's first go and create this data. Alright, so there you go. So data is created. Now let's go and analyze the data a little bit. Okay, so first of all, I want to understand how the X train looks like on the array position 50, right? So I'm gonna say shift enter, and this is how it looks like. The 50th sample looks like this. So this is the data distribution. So you have 20 points, right? And this is how it looks like. How does Y train looks like? So it looks like this. So this is a class distribution. So you see that you have classes and basically 0 or a 1. So 1 means this is the class this sample belongs to. So this distribution of 20 points belongs to class 8. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is A8. So that's how you need to understand this. So you can also do that with the X test at the position 0. This is how the X test looks like, and the Y test at the position 0 looks like this. So this distribution belongs to the 9th class, or the 10th class. The position is 9, just to be clear. All right, really good stuff. So now we have the data. Now what we gotta do is we gotta create the model. So for that, you're gonna use the sequential model, and then you're gonna use the add method to add the different layers. So first is the dense layer, and it has 64 neurons, and activation is value, and input dimension is 20. That we already have seen this. Then you're gonna add a dropout, and it's gonna be 0.5 for that. Then another dense layer with 64 neurons, activation is gonna still be value, another dropout. Finally, a dense layer with 10 neurons, obviously that should be the same as the number of classes. Since you have 10 classes, this should also be 10. Activation is going to be a classification, so softmax. All right, so the optimizer here you're going to be using is SGD, and SGD takes a set of arguments which you can pass to it, right? So if you don't understand that, let's go to optimizers here, and let's go to SGD here, and these are the arguments it takes. So learning rate, very important, momentum, decay, and nested row. So read a little bit about it. We also seen a little bit about this while working with the IBM Watson. All right, really good stuff. And then finally, you're going to pass all this information to the compile to compile this model. And along with the information above, you also have to pass the loss function. This is going to be in this case, it's going to be a categorical cross entropy, and also the metrics you want to use. So in this case, it's going to be accuracy. So far what we've done is we've imported the libraries, you created your data, all right? You also analyze your data, you have created your model, and then you're going to compile it. And then the next step would be to train it. So let's go ahead and run this. So far we have the data. Let's create the model. So let's go and say shift enter here. So there you go, the model is created. Next is to compile it. So let's go and say compile. There you go. So this is done. 59. Okay. So we are all ready for the training. So when I call model.fit, this network is going to start training. And keep in mind that the epochs here is 2000. So you may want to reduce it just for demonstration purposes. Let's say 8000. Okay. And then the batch size is 128. So once you actually train the model, then we will evaluate it, and then also we will do a bunch of stuff. So let's first go ahead and train this. Now if you want to reduce this or increase this, obviously you can do it. For me, I'm going to run it with 1000 and let's see what happens. All right, so let's go and say shift enter, and let's see how this works out. So this is epoch 1, as you can see. So it doesn't take much time. All right, it's done. So that's the actual time it took. I did not edit the video, so that's actually the amount of time it took. So there you go, it's all good to go. All right, so now you need to evaluate the model. So basically understand what really happened by calling the model.evaluate, and then you're going to store the values in a variable called score. All right, let's say shift enter, and now it has the information. So what is the information score is trying to tell us? That we can understand by calling this model.metrics underscore names. Let's go for it. So basically it's going to tell us the loss and the accuracy. So now if I call score, it's going to tell us the loss and accuracy. There you go, 2.4 is the loss and accuracy is 0.15, which is not really good. So of course you can increase your iterations, and this will probably increase. Of course, you can add more layers. You can do all the techniques which we have learned so far, and then change it and see what happens. And this whole process is extremely easy when you actually get to learn and use the Keras library. For example, I can simply add another layer here. Just by doing this, that's it. So here you have another layer all ready to go. Since this is not the first layer, you don't need to pass the input dimension. So not only that, you can also change your activation, you can change the number of neurons, you can change different layers, and of course change its parameters and so on. You can also change the optimizer and learning rate and so on. So go ahead, try a couple of variations and see how it performs. Okay, so now it's time to actually take a look at how the prediction works. So let me get the score again. This is our score. I ran another permutation, so that's why you see a small change here. But I brought everything back to 1000 and everything else is the same as per the example. All right. So now what we're going to do is we are going to predict by passing a actual sample. So I'm passing a actual sample from the training set itself to the network. And let's see how it performs. So let's see, counter shift, there you go. So this is the confidence level for each of the classes. So in this, you can say that the highest confidence is the class number 10, that's 0.25, right? Now, actually, let's go and see what was the label or what was the class. So actually, the class was the 10th class. So this time you got lucky. And of course, you see the confidence factor is very low. It's only 25%. This should be like 95 if you want to make this model useful. Okay, you want to try something else? Let's go and take another piece here. Let's say 45, 46. And let's go and first predict on it. In this case, the network thinks that this is a class number 1, 2, 3, 4, 5, 4 or 5. Yeah, so basically 4 or 5. Now, if you want to actually compare these two, the 5th class is slightly higher than the 4th class. Okay, perfect. Now let's actually go and see what the label was. So 45, 46, and it was actually the 4th class. So there you go, you getting some results, but of course this needs a lot of improvement. So go ahead and try and see how it works out for you. Really good stuff, really good learning.